stuck between a rock and a hard place, they had to invent a third way out. And this led to the absolutely brilliant solution they called static.
And that's what everyone thought too, but this is exactly where the engineers hit a massive, massive speed wall.
The issue is a fundamental mismatch, a language barrier, really. The classic, old-school algorithm for this job is called a prefix tree, or a trie, and it works by following a path one step at a time, kind of jumping all over the memory. But modern AI hardware, your TPUs and GPUs, they hate that. They're built for what's called vectorized operations, processing huge, predictable chunks of data all at once. So you have the old logic that's random and scattered, and the new hardware that needs everything to be neat and tidy. They are, as the paper says, fundamentally hostile to each other.
And the result of that hostility? A truly catastrophic slowdown. Trying to use that classic method added over 31 milliseconds of lag for every single token the AI generated. That's an eternity in computer time.
So let's be super clear. This wasn't just, oh, it's running a little slow. No way. This was a complete and total deal breaker. For a service like YouTube that has to work in real time for billions of people, that kind of latency makes the whole idea completely unusable. So they were stuck. They could either have a smart but totally unreliable AI or a reliable one that was unusably slow.
So, stuck between a rock and a hard place, they had to invent a third way out. And this led to the absolutely brilliant solution they called static. It's a completely new way of thinking about the problem that's built for modern hardware.
The big aha moment was a total shift in perspective. Instead of trying to force this slow, step-by-step logic onto super-fast hardware, they asked a different question. What if we could translate the entire rulebook into a language the hardware already speaks perfectly? It's like they swapped a creaky old turn-by-turn treasure map for an instant GPS that shows you every possible route, all at once.
And that's exactly what static is. It stands for Sparse Transition Matrix Accelerated Tri-Index, which is a mouthful, I know. But the idea is genius. It takes that big, complex, branching tree of rules and flattens it down into a giant but super efficient map called a sparse matrix. This completely transforms the problem from a slow, one-step-at-a-time process into a single, lightning-fast calculation that GPUs and TPUs were born to do.
The process itself is just elegant. First, way ahead of time, they flatten the rules into this hardware-friendly matrix. Then, when you're actually using YouTube, that slow, step-by-step checking process gets replaced with one single, vectorized lookup. And this is crucial, the whole thing happens right on the AI chip itself. No more slow back-and-forth chatter with the CPU that just crippled the old method.